So last class we started with complex numbers, and in complex numbers we discussed the concept of representation of complex numbers, and in that we were doing point form representation. And in point form I basically completed about modulus of a complex number, right? So last class, quick recap, we stopped at modulus of a complex number. Modulus of a complex number. So what did we discuss there? Modulus is basically nothing but it represents the distance of the complex number point z from origin, right? So what does complex number modulus represent? It represents its distance from the origin on the eigenplane. Okay, on the eigenplane. And what was the working formula for that? So if your complex number is a plus bi, the modulus of that complex number was under root of a square plus b square. Okay, this is what we had done in the last class. Okay, so today I'm going to begin my discussion. With argument of a complex number, better known as principal argument. Principal argument of a complex number. Okay, please pay attention to this concept because this is very critical. If you don't understand this, you will have problems in understanding the concept of polar form. Yeah, so principal argument of a complex number. What is principal argument of a complex number? How it is represented? First of all, it is represented by this symbol ARG, and in bracket we write the complex number. Okay, ARG stands for argument of a complex number. So let me define this for you. We'll first define it geometrically, and then I'll give you a mnemonic or a formula for finding the principal argument of a complex number. So geometrically speaking, geometrical significance of argument. So geometrically speaking, principal argument represents the shortest angle. Okay, the shortest, in fact, I would like to make a small correction to it. It's the shortest unique angle. Is the shortest unique angle between the positive real z axis, or let me write it in short form, REZ, and the line segment connecting Z with origin, measured from the positive real z axis. Okay, so it's very simple. It's nothing but it's the shortest unique angle. Unique means only one possible value of argument or principal argument can come. You cannot have multiple principal arguments. The name principal itself means the main guy, like how we have principals in our school. So he's the main person of the school, isn't it? So principal can only be one. You cannot have multiple principals. So that is why it's a unique angle. It's the shortest unique angle between what? Between the positive real z axis and the line segment connecting z with origin. And note that this measurement has to start from the positive real z axis. Okay, let me give an example for this. Let's say I have a complex number. Let's take 1 minus I or 1 minus 1 plus I. Okay, let's say I take a complex number like this. Now, if I ask you this question, what is the argument of Z here? So what are we going to do here? We are first going to represent 1 minus 1 plus I on the Argand plane. So we know this is an Argand plane. It's a plane which is made up of the positive, it's made up of the real Z axis and the imaginary Z axis. So on this plane, minus 1 comma I will be like a point here. Isn't it? Yes or no? Now let's connect this Z to origin. So I'm making a line segment connecting Z to the origin. Right? Now starting from positive real Z axis, this is your positive real Z axis, isn't it? So from here, you start moving in a shortest angle. So what will be the shortest angle, tell me? Should I go like this for the shortest angle? Or should I go like this? White one or the yellow dotted one? Which one? All right, white one, exactly. So this is not the shortest, right? So I'm just erasing it off. This is the shortest, right? So tell me, when you're going from positive real Z axis to hit this line OZ, right? What is the direction of your movement and how much are you moving by? So it says the direction is anti-clockwise, so it's a positive value. Remember, angles are positive when you are measuring them in an anti-clockwise direction, and they are negative when you are measuring them in a clockwise direction. So that basic sign scheme of angle you should not be forgetting. So you should be applying the same over here as well. Now, what is the magnitude by which you have moved? Can anybody tell me the magnitude? Right, 135 degrees. So we can say plus 3 pi by 4. Exactly. So the argument of minus 1 plus I is nothing but it's plus 3 pi by 4. Normally we don't write a plus. So this is your answer. Clear? Any questions, any concerns here? Would you like to do one more example? Okay, let's take this one. Let me take minus 1 minus I. I would request all of you to try this out. What is the principal argument for this case? Please do it. I'm not doing it. I want response to come from your side. No, Arthur, that is not the right answer because that is not the shortest angle. No, Naren. But good try. I'm just happy to see people trying here. Starting from the positive real Z axis, you hit the line connecting Z with O. That angle is your answer. Absolutely right, Raj. Well done. Well done, Pranav. No, Shreya. Same mistake. Same mistake. No, Vikram. Okay. Let's discuss this. Let's discuss this. See, minus 1 minus I is here, isn't it? So it's like minus 1 comma minus 1. This is my Z. I connect this to the origin. I connect this to the origin. So this is the line connecting Z with the origin, right? Now starting from here, starting from positive real Z axis, I have to move in the shortest angle possible to hit this line OZ. So of course I cannot go from top. I have to go from this direction, right? But mind you, when I'm moving in this way, I am moving in a clockwise direction, right? So clockwise means my argument will become a negative angle, right? Clockwise is negative. And what is the magnitude by which I have moved? That everybody knows. That's going to be 135, isn't it? So for finding that, things are very simple. Treat as if this is a right angle triangle whose this is 1 and this is 1. And let's say somebody is asking you what is the magnitude of this angle phi. Obviously, you'll say 45. So this becomes 135 magnitude wise. But minus 135 will be written as the answer because it is measured in a clockwise direction. Is that fine? Let's take more examples, not to worry. Let's take more examples.
So please could you go to the definition for a minute? I'll just quickly take a snap of it and note it down.
Yes, yes, sure.
Done, sir. Thank you, sir.
Yeah. Okay. Let's take another example. Let's say my complex number is 3 minus root 3i. What is the principal argument of this complex number? We'll discuss everything, Raj, not to worry. That should be actually my question. You are only asking me that question. That don't worry, we'll take those as our list of questions. So argument we are going to do in much more detail. Yeah. Answers for this, please. Very good, Pratik. Anybody else? Raj, are you sure? Are you sure of your answer? Ah, very good. Okay, let's discuss it out. See, very simple. If you write this as a point, it's 3 comma negative root 3. So it's somewhere over here, right? 3 comma negative root 3. Okay. Let's connect this to the origin, right? So this is your connection of Z with the origin. Now, starting from the positive real Z axis, move in the shortest angle to hit this line. So obviously, when you're moving, you will be moving in this direction, right? What is this direction? Clockwise or anti-clockwise? Clockwise or anti-clockwise? Clockwise. Yes, so clockwise is negative. And by how much have you moved? For that, think as if there is a triangle given to you whose base is 3 and opposite here is root 3. So how much is this angle's magnitude? Let's say I call this angle as phi for the time being. So what is tan of phi? Tan of phi here you'll say root 3 by 3, which is 1 by root 3. So phi as an angle is 30 degrees or pi by 6. So the answer to this question is minus of pi by 6. Is this fine? Any questions? Okay. So one last example I would like to take here because this is for some reason. If I give you a complex number like minus 3, tell me what is the argument of this complex number? See, no, not necessarily you should write your angle in radians, but later on in some of the forms like Euler's notation, you have to keep your argument in radians. We'll discuss it, but as of now, you can write it in degrees also. Why you are still not comfortable with radians? Start thinking now and applying writing in terms of radians. Okay, Saket, very good. Anybody else? So I'm getting three different types of answers. Some of you are saying 180°. Some of you are saying 0°. And some of you are even saying minus 180°. Okay. Now, I can understand the people who are saying 180 and minus 180, but I cannot understand why people are saying 0° also. See, if I write minus 3 is here. Correct? No? Correct? So starting from the positive real z-axis, if I have to make a movement to hit this OZ, okay? Now, I need to cover shortest angle, right? So one school of thought would be, this could be my shortest angle, right? And then you'll say pi for this, isn't it? I'll make it again. Yeah, from here to here, this will be pi. But some of you can also think, why not from here to here in this direction? But in that case, your answer will be minus pi, right? Which one should I accept then? Because both are shortest, right? But I can only accept one, my dear, because remember I told you it's a principal argument. Only one answer is possible. Only one unique value for a principal argument is possible, right? So here is something which I purposely did not give you in the beginning, but now I'm giving you. Your argument is always an angle between minus pi to pi, exclusive of minus pi and inclusive of pi, right? So this particular restriction was basically placed because mathematicians knew that if you have a complex number lying on the negative real z-axis, there are two shortest paths. One could be this way, another could be this way. So because they ruled out negative pi, now there can only be one answer, which is pi. So the answer in this case is 180° or pi, not minus pi. Is it fine? So people who said minus 180°, it was no mistake of yours. It's just that now you add one more thing to your definition, that your argument, your principal argument should always be between minus pi to pi, minus pi exclusive, pi inclusive. Clear, everyone? Any questions? Okay. So with this, let's take a quick round of questions where I will be giving you complex numbers and you will be telling me the principal argument for those complex numbers, right? Let's begin. Write the principal arguments, write down the principal argument for the following. Let's take 0 as a complex number. Let's take 5. I've already taken minus 3, so negative numbers will be able to answer very easily. Let's take 2i. Let's take minus 5i. Let's take something like minus half, or minus half minus I root 3/2. Let's take 2 times cos pi/6 plus I sin pi/3. Yeah. Let's do this one by one. Please ensure you have answered everything before putting a response on the chat box. Put your question numbers next to it, next to your answers. And after writing everything, then only press and enter. Else what will happen? You will answer one, somebody else will answer the first part again. Then there will be a big confusion in my mind to know who has answered everything correctly. Okay, Naren, very good. Let's wait for this. Okay, should we discuss it now? Anybody about to finish and wants some more time? I can wait. Okay, maybe 30 seconds more or 1 minute more. Sure, Vikram. Take your time. Okay, Atar. Okay, let's discuss this out. So for the first one, most of you have written 0 for it, but you'll be surprised to know argument of 0 is undefined. Now 0, why argument of 0 is undefined is because if you have a line connecting 0 to itself, and still is a point, right? So what is the direction of a point from the positive real z-axis? Nobody can figure that out. It's like saying, what's the direction of a null vector? Right? What's the direction of a null vector? Undefined, isn't it? What's the degree of a 0 polynomial? Undefined, right? So the first answer is undefined. Okay. So those who have said 0 for the first one, sorry, the answer for the first one is undefined. For the second one, yes, you're right. For the second one, the answer is 0, right? Because if you make 5, 0, let's say this is my 5, 0, the line segment connecting 0 with z, that is making an angle of 0 itself, right? Is it fine? Any questions? Okay. Third one, the answer is pi by 2. Third one, the answer is pi by 2. Why? Because 2i is like 0, 2 on the Argand plane, right? So what is the angle? Shortest angle is this angle, and measured in an anti-clockwise, it's a positive pi by 2. Okay. Fourth one, minus 5i, argument is minus pi by 2, right? Most of you have got this right. So minus 5i is like 0, minus 5. So this is the shortest angle, right? Next one, fifth one, minus half minus root 3 by 2. So something over here, minus half minus root 3 by 2, right? So now here, if you want to know the shortest angle, it will be this path. Since you're measuring it in an clockwise sense, it will be a negative angle. And now what is the magnitude of it? For magnitude, if you make a small triangle here, this will be half, this will be root 3 by 2. So this is 60 degree in magnitude. So this is going to be 120 degree in magnitude. So the answer for this whole part will become minus 120 degree, which is negative 2 pi by 3. Okay, so fifth answer is negative 2 pi by 3. Some of you have got this wrong. Can you please check why you went wrong? And please ask if you are not getting that point. Why it is negative 2 pi by 3? Is that clear? Okay, great. Next one. Now, if you want to know what is the argument of this, you have to expand it. So 2 cos pi by 6 is 2 root 3 by 2. And I times 2 sine pi by this thing is again root 3 by 2. Correct? So what does this become? It becomes root 3 plus I root 3. Right? So on an Argand plane, it is at root 3 comma root 3. Okay. On the Argand plane, it is root 3 comma root 3. Correct. So what is the shortest angle? This is the shortest angle. Okay. And it is measured in anti-clockwise. And this magnitude will be 45 degrees because even the opposite is root 3, base is root 3. So this is 45 by magnitude. So the answer to this question is, I'll not write down the whole thing. I'll just say arc Z. That is going to be pi by 4. Well done, Arthur. Your answer is absolutely right. Is this fine? Any questions? Any questions? Any concerns? But I could figure out many of you are making mistakes. So maybe I think I should take one more round because if you're making mistakes here, you will also make mistakes in the polar form, which we are going to take up after this. So let me take one more small round. Okay. All right. So let's take 7th one. This time my complex number that I'm going to take is 1 minus root 3i. Let's take minus 3 cos pi by 3 plus I sine pi by 3. And let's take this one, minus 1 yeah, 7, 8, 9. Let's do this quickly. 1 minute is what I'm giving you for this, not more than that. Just a minute. This time I'm expecting everyone to give me the right answer. These are all basic concepts, dear all. If you make mistakes here, the subsequent concepts will also get affected because of that. And this is a part and parcel of your school testing as well, right? So you'll be tested on these concepts even for your school UTs and semester exams. Okay, Naren. Shall we discuss? Okay, ready, everyone? Okay. So 1 negative root 3i is basically in the fourth quadrant like this, isn't it? So 1 comma negative root 3, right? Any problem? No problem, right? Now, let's start with the positive real z-axis and start moving towards OZ in the shortest possible way. So what is the shortest angle that you can realize? So you'll say this is the shortest angle. So for making this movement, you have to definitely take a clockwise route, isn't it? So the first answer has to be a negative value. Now, what is that? Now, what is that full value of this argument? Negative is the sign. And what is the magnitude here? Now, see, if you make a small triangle here, this will be very obvious that since it is 1 comma root 3, you have gone 1 unit here and root 3 unit down, right? So as a triangle, its dimension will be 1 as the base here and root 3 as the opposite or perpendicular. So magnitude wise, this is 60 degree, but since measured in a clockwise sense, you will say it's minus pi by 3. Absolutely right. Some of you have got it right. Okay, correct, Anika. Arthur as well. Okay. Next one. Next one, eighth one, if you just expand it, this is actually negative 3 by 2, right? And this is going to be I or negative I 3 root 3 by 2. Am I right? So when you represent this point on the Argand plane, it's going to be in the third quadrant. So I'm just putting that in the third quadrant here. So it's somewhere over here. Let's say, okay, negative 3 by 2, negative 3 root 3 by 2. Okay. So let me connect this. Now, obviously, when I'm finding this angle, shortest route from the positive real z-axis till I hit OZ, I have to take a clockwise route. So this is definitely a negative answer. Let me write ARG. So for this, ARG is a negative value. Okay. Now, what is the magnitude by which I have moved? Again, same simple process. Make a right angle triangle. The base here is 3 by 2. Height is 3 root 3 by 2. So again, here this will be 60 degree in magnitude. So this will be minus 120 degree now, right? 120 as a magnitude and minus because it is clockwise. So minus 120 or minus 2 pi by 3. That would become your answer for this question. Is this fine? Any question? See, Shreya, very simple. Let's say I make this triangle like this. This is 3 root 3 by 2 and this is 3 by 2. Okay, and I ask you, what is this angle's tan value? What will you do? Opposite by base. So 3 by 2 will go off. So you'll get root 3. Right? Yeah. So tell me, for what value of phi tan gives root 3? Obviously, your response will be pi by 3. So if this is pi by 3, this is 2 pi by 3. But that is magnitude. You have to attach a sign to it to get your full answer. So sign will be negative because it's a clockwise angle. Clear? Okay. Last one also, the same story will go. Maybe I should make another diagram here. So minus 1 minus root 3. Again, you are in the third quadrant. So this is something like this. So this is your Z, this is your O. Connect Z with O. Start from positive real Z axis. Move in such a way that you hit this line. Now you're moving in again anti-clockwise. So for this also, the answer would be some negative value. Now here again, this is 1 and this is 1 by root 3. So this time the phi value here will be pi by 6. So this is minus 5 pi by 6. Right? Because this is pi by 6. So this thing should be 5 pi by 6. Complementary of that. And you're moving in clockwise sense. So it will be negative 5 pi by 6. Is this okay? Any questions? Now, many people ask me this question, sir, is there any direct formula? Because you don't want to always make diagrams like this and solve it. As if making diagram will take more time. No. diagrams sometimes, or these representations sometimes make your life easier. Okay, but still, I'll give you a mnemonic, I'll give you a formula, I'll give you a trick to find out the argument, principal argument of any complex number quickly. Okay. Not really, Naren. Okay, let's talk about this. So, formulae, or you can say trick, not a formula. It's more of a trick, or maybe a mnemonic, a shortcut. Shortcut to find principal argument. Shortcut to find the principal argument. Okay, now here, all of you please pay attention. So let's say you have been provided with a complex number a plus bi, right? So what is the first thing that you are going to do? You are going to first find out tan of which angle gives you mod b by mod a. Okay, so from here, find phi. Okay, now when you're finding this phi, of course, keep your answer only in the first quadrant. Okay, so your answer should be restricted to first quadrant only, 0 to pi by 2, right? Because tan of phi is a ratio of two positive quantities, so it is a positive value. So you may also get an answer in the third quadrant. But no, we don't have to go to the third quadrant, because in fact, whatever I'm going to use phi with, or whatever utilization I'll be making with phi, that is already sufficient enough if you take an angle between 0 to pi by 2 only. Okay, now see. In the second step, you just have to follow this mnemonic. If your complex number z falls in the first quadrant, that means a is positive, b is also positive, then remember, the argument of this complex number will be as good as this phi. Whatever phi you have found out, that is going to be your argument. Okay. If your a is negative and b is positive, that means you are in the second quadrant. Then the argument would become pi minus phi. Right, Naren. Is it fine, everyone? If you're falling in the third quadrant, that means a is also negative, b is also negative, then in that case, the argument becomes phi minus pi. And if your a is positive and b is negative, then in that case, argument is going to be negative phi. Then your argument is going to be negative phi. Is it fine? Any questions here? Now, what if your complex number falls on the positive real z-axis? If it falls on the positive real z-axis, then in that case, your argument will be 0. Okay. If it falls on the positive imaginary z-axis, then your argument will be pi by 2. If it falls in the negative real z-axis, your argument will be pi. If it falls in the negative imaginary z-axis, your argument will be minus pi by 2. And if it is at origin, that means your complex number is 0, then the argument is undefined. Okay, so these are the things you need to keep in mind. So let us utilize this formula to get our arguments. Let us say somebody gives me, what is the argument of 3 minus 3 plus root 3i. Okay, let's say this is the question. So if I don't want to represent this on the argand plane and then figure out what is the shortest angle, I directly want to use a formula. I'm a formula guy. So what I'll do is I'll first find tan phi. Tan phi will be what? Mod b by mod a. Mod b by mod a. Mod b is root 3 only. And mod a is 3. So this is 1 by root 3. So tell me an angle between 0 to pi by 2 for which tan phi gives you 1 by root 3. I'm sure everybody knows the answer, pi by 6. But now, this is A negative, B positive case, means you'll fall in this category. A negative, B positive case. So your argument in that case would become pi minus 5, which is nothing but pi minus pi by 6. So the answer to this question is 5 pi by 6. Is it fine? Any questions? Any questions? Shreya? Okay. All right. Now, this is for your school level stuff. Let's see what our competitive exams will be interested in. So let me give you some questions based on argument which may be asked for your competitive exams or which you are supposed to know for your competitive exams. But first make a note of this, and if you have any questions, please let me know, because this is something which is going to be useful little later on as well. Okay. Shall we move on? People have copied this. Okay. So now next question is something which is related to your geometrical understanding of what's a principal argument. Okay. So on an eigenplane, represent all such complex numbers. Let me call them as Z, which satisfy first one. So it's the first question, which satisfy argument Z is pi by, let's say, 3. Make this on the eigenplane. And of course, you cannot give your response on the chat box because this is a drawing that you have to make on your respective notebooks. But once you're done with the drawing, just say are done, right? You don't have to tell me how you made that drawing. If you want, it's up to you. I'm leaving up to you, right? Make this diagram showing all such complex numbers Z, which will have an argument, principal argument of pi by 3. So sorry. Okay, so Naren is done. Anybody else? Arthur done, Saket done. Okay. So Anika also done. Okay. Ritik also done. All right. Now most of you would have made a ray starting from origin at an angle of 60 degree and going all the way up here. Correct? So this angle is what? 60 degree or pi by 3. Correct? Right? Have you done this? All of you have done this? Anybody who has not done this, let me know. Say yes if you have done the same thing. Okay, now whoever is saying yes, you're wrong. What, sir? You are joking, right? No, that is even more wrong, Naren. It will not go to the third quadrant. What you all are forgetting is there will be a hole here. Right, Saket? So there will be a hole at the origin. How many of you have made this hole? Not many. I think only Saket did that. Now, why there is a hole there? And why without a hole it will be wrong? Right? There will be a hole because it signifies that origin will not be that part of that Z. Because if you're saying origin is included in your answer, it is like saying argument of origin is pi by 3. But we already have seen argument of origin or 0 is undefined, right? So you have to show this hole. And let me tell you, when you get this question in the competitive exams, in the options, they will put one of the option with a hole, one without a hole. Okay. So it will be all the complex numbers which lie on this line or this ray, so as to say, but it would not include your origin. That is very important to be taken care of. Okay. Now somebody is saying, why won't it go to the negative? Why won't it go backwards? Why don't we go here? See, if I come here, what will happen? If I take any complex number here, this will have a negative argument, right? In fact, its argument will be negative 2 pi by 3. How can you say its argument is pi by 3 then? Right? So that part will not be a part of your answer. Is it fine? Any questions here? Okay. Tricky, but a good learning for all of us because many of you made a mistakes here. Okay, let me ask this question. Argument z greater than pi by 3. Can you show or can you shade that region where all such complex numbers whose argument is greater than pi by 3 will be lying? Do it on your respective notebook. Show it on the Argand plane. Just say you're done if you're done. Done, Ritvik. Good. Done. Very good. Okay. So here, the diagram will look like this. First of all, the ray that you will be making will be a dotted ray. Okay. Secondly, there will be a hole here. Okay. And everything on this side will be shaded. Yes or no? Is this the answer or is this the diagram that you all are getting? This is pi by 3. No? Then Pratik, then your answer is wrong. This time I am not trying to trick you. This is the final answer. So Pratik, tell me what is something that I am missing here according to you? Why is this line dotted? Very good question. See, Kaustav, here you have greater than, not greater than, equal to. That means if you start shading from this line, then what will happen? You are trying to claim that even pi by 3 is a part of your answer. No, your argument should be more than pi by 3. Clear? That is why the line has been made as a dotted line. Clear? Pratik is still waiting for his answer. He has not said anything. But anyways, we'll move on. Okay. Show this on the Argand plane. Argument of z is less than equal to pi by 3. Please make this on the Argand plane, everybody. And let me know with a done once you're done with it. By the way, whenever you are making an Argand plane, it's a good practice that we write the name of these axes, because we are so involved into solving the problem that we miss out on the basics, and this will lead to some loss of marks in your school papers. Done. Very good. So here what I'm going to do is, okay, I'm going to make this pi by 3. Okay. And now this time, please be very, very careful. Hole will be definitely be there. And this time we'll be shading down, but even this line will be dotted. Even this line will be dotted. That means your shading will be like this. Getting the point? Now, why is this line dotted? Why do you think I have made this line dotted? Right? Because on that, any complex number will have an argument of pi. So you can't say pi is lesser than equal to pi by 3. Right? So you have to stop just before that line. So any complex number which will lie in this zone, that will be satisfying this particular criteria. Is that fine? Any questions? Okay. So one last one we'll take on. In this case, I'll give you two conditions. One is modulus is less than 2, and at the same time, let me write it in white only. Modulus is less than 2, and at the same time, your argument is from pi by 6 to pi by 3 exclusive, pi by 6 inclusive. Show this on the argument thing. Done? Okay. Should we discuss? So first of all, mod z less than 2. Mod z less than 2 means what? You are within a circle, correct? Circle whose radius is 2 and center is at origin, right? But mind you, since it is a pure inequality, you will have to make your circle as dotted, right? You can't make a solid line circle, right? You have to make your circle as dotted. Okay. Now you are within the circle, and simultaneously you have to be also satisfying that the argument should be between pi by 6 to pi by 3. So I'll make pi by 6. Oh, sorry. I have to choose a line. Yeah. Pi by 6 like this. Okay. And pi by 3, let's say like this. And my pi by 3 line will be dotted because pi by 3 I cannot touch. At the same time, origin should also be dotted. Okay. So I have to be within the circle also, and I have to be between these two rays also. So which part is falling in that zone? You say this particular sector is falling in that zone. Is it fine? So all complex numbers which fall in this zone, they will be satisfying these two conditions of argument and modulus simultaneously. Is that fine? Any questions? Any questions? Any concerns? Okay. We'll talk more about it. It's just the beginning of the concept. We are going to discuss modulus argument based geometrical representations quite a lot in solving many complex number questions. So meanwhile, with this, we will now move on to our understanding of the second representation of complex number, which is the polar form. So let me take you to the next concept right now. But before I move on, if you have any questions, any concerns, please feel free to highlight. Okay. All right. So let's move on to the next concept. So this is the second form of the representation. So I'll write polar form, also called as trigonometric form, also called as the vector form. Now this polar form is obviously inspired from polar coordinates. Now remember when we were doing harmonic forms of an expression in trigonometry, we had briefly touched upon polar form, right? Sorry, we have briefly touched upon the polar coordinate system, right? Polar coordinate system was the brainchild of Newton. So he basically said that if you want to locate a point, let's say point is A comma B, right? So he said if you want to locate a point A comma B, you can locate it by mentioning two things. One, how far is this point from the pole? So he called origin to be pole, right? So he said this distance and this angle. By mentioning these two things, you'll be able to locate a given point on the Cartesian plane or on the R square plane. Actually, it's an R square plane only, but sometimes we also call it as a Cartesian plane because of the contributions made by the French mathematician René Descartes. But actually, many other people also have made contributions to the field of coordinate geometry, Newton being one of them. So he came out with the polar coordinate system, right? So how is this R and theta connected to this A and B? How is this R and theta connected to this A and B? Very simple. If you make a triangle over here, you know that this is R cos theta. This is R cos theta. And this is R sin theta. Isn't it? So your A is R cos theta and your B is R sin theta. Isn't it? Now start treating this to be a complex number. Let's say if I take Z to be a complex number A plus BI. Correct? Right? Can I say the very same R will now be your modulus? And the very same angle that you are not talking about will now be the argument of that complex number. Isn't it? So when I write it in form of R and theta, this is what I am going to see. Correct? So take this R common, write it like this. Okay. And what's your R? R is modulus. And what's your theta? Theta is the argument over. Right? So the whole idea of modulus and argument that will help us to write down the polar form of a complex number. So this is the point form. This is the point form. And this is the polar form. Getting it? So it's just another way of representing a complex number. Is this fine? Many people call this in short form or abbreviated as, this is also abbreviated as R cis theta. But I'm writing it here in red, not to be used in school. Don't use this representation or this form of representation. Okay. Don't write R cis theta in school. Is it fine? So I have nothing to teach you here because you already know modulus, you already know argument. But yes, I can give you. Cartesian plane is completely real. Cartesian plane is in a R square plane. But here I have actually kept it as the Argand plane. So I'm bringing that concept of real plane into Argand plane to solve it. Got it, Krishnendu? That's the logic behind it. Yeah. So I'm borrowing a polar coordinate system and I'm fitting that R of polar with our modulus Z and theta of polar as my argument Z. to address or come to this particular form. Okay. So there's no problem borrowing from one concept to represent something else. Okay. So can we take few questions where I would ask you to write down the polar form for some complex numbers? Let's take some question. Write the, in fact, let me check if I have a question on my question list. Normally, I should be having one. Where is it? Where is it? Where is it? I think so. I should be having one. Uri Baba. Not there. Right. Let's take this question. Write down the polar form for minus half minus I root 3 by 2. In fact, we'll take many more questions. This is just one of them. We'll take many more questions. Let's begin with this one because this is easy. And when you're writing your answer, as of now, in the chat box, you can use this expression in the chat box, r says theta, so that you save your time. Right? So it's nothing but mod z cis argument. Kaustav, is this what you wanted to see? Let me know once you're done so that I can go down to the question. Okay. Done. Very good. Sakit. See, let's use our formula here. So in the polar form, you know, the expression is mod z cis arg z, right? So what is mod z here? Mod z will be under root of half minus half square and negative root 3 by 2 square, right? So that's going to be 1/4 plus 3/4. 1/4 plus 3/4 is a 1. Under root of 1 is a 1, right? And I'll be using my formula or the shortcut way to find the argument here as well. So first let me find phi. Phi will be, or you can say tan phi. Tan phi will be mod b by mod a. So mod b by mod a. So that's going to be root 3. So phi is going to be 60 degrees. But remember, we are dealing with a scenario where my complex number has both a and b negative. So you're here. So in this particular quadrant, your argument is phi minus phi. So here your argument will be phi minus pi, which is minus 2 pi by 3, correct? So the answer to this question is 1 cis negative 2 pi by 3. This is your answer. Is this fine? Any questions? Any questions? Any concerns? Okay. Let's take a few more questions. Write the polar form for the following. For the following. No, no, no. If you're finding the value of cos 120, sin 120, etc., you are back to the point form only, no, Krishnendu. See, what you have written is another representation of the same thing. If you simplify that, you are back to the same thing again, no? Correct? Kaustubh, you are not paying attention. That means you're asking me a question which is in this diagram. Where was the diagram? Oh, it was in the previous slide. So you missed out copying something. You were away from your keyboard, AFK, or writing something on Discord. See this. Kaustubh, not to Krishnendu, Kaustubh. Why did I subtract pi from 5? This is the reason. Because A and B are negative, isn't it? Clear, Kaustubh? Okay. You are unmuted. Let me mute you. Okay. Let's write down the polar form for the following. First one, -2. Let's take √3 minus 3i. Let's take 6i. Let's take -3 cos pi by 6 plus I sin pi by 6. 2 cos pi by 3 plus I sin pi by 6. Let's do these 5 only.
No, what's the last question? Z is equal to.
What happened, Vikram?
No, what's the last question? Z is equal to. Z
Z is
8.
equal to 2 cos pi by 3 plus I sin pi by 6. This is 2. Sorry if it was not legible. Now it is legible. Done. At least the first three, are you done? Okay. So first one, check your answer. -2 is 2 cis pi. Everyone got it? Okay. Second one, check. Modulus is root 12. Root 12 is 2 root 3. Okay. And here tan phi will be 3 by root 3. 3 by root 3 means root 3. So phi will be 60 degrees. And since this lies in the fourth quadrant, that means your A is positive, B is negative. This answer will be cis minus pi by 3. Clear? Any questions here? Yeah, I know the internet is not that great today. Now am I audible? Okay, next one. Third one, your answer will be 6 cis pi by 2. Six cis pi by 2. Clear? All right, coming to the fourth one. Anybody who could answer the fourth one? Is my voice still breaking up?
So now it's better. Now it's better.
No, it's fine. Okay. Maybe I can switch off my camera for some time so that the bandwidth is saved. Yeah, fourth one. Okay, very good, Saket. Okay, let's discuss this. So for solving this question, many of the students initially get confused. Okay, they say, sir, isn't this already in the polar form? Right? Mind you, it is not. Right? Because R can never be a negative value. It is always a non-negative value because it represents modulus. Right? So this is what we call normally what I call as a Chinese polar form because of the fakeness. Right? This is fake. Right? So it may give a feeling that it is already in the polar form, but it is not. Right? So how do we solve this? So we normally equate this. We normally equate this to R cos theta I sin theta. Okay. Now when I'm comparing it, I'll compare the real part here with the real part here. Okay. And I'll compare the imaginary part with the imaginary part here. Right? Mind you, R and theta is what is I need to complete the polar form. So I'm looking for R and theta here. So I have these two equations with me. Okay. So what I'm going to do to get R, I'm going to square both of them. So I'm going to square 1, square 2. So when I do that, I get R square cos square, R square sin square. Here also I'll end up getting 3 cos pi by 6 square. Let me write it like this. And here also this will be 3 square sin square pi by 6. So take a 3 square which is 9 common. You end up getting cos square pi by 6 plus sin square pi by 6, which is happily 1, right? And here also we get an R square if I take an R square common, right? So R square is 9. So R is plus minus 3, but mind you, I will only take 3, not minus 3. Right? Why? Because R is the modulus. So I cannot take a negative value for R. Got it? Now, put this back in 1 and 2. Okay, put this back in 1 and 2. So if you put it in 1, what do you see? Minus 3 cos pi by 6. By the way, cos pi by 6 value is root 3 by 2. Is 3 cos theta, which means cos of theta is negative root 3 by 2. Similarly, minus 3 into half is 3 sine theta. That means sine theta is minus half. Now, what should be your theta for which? What should be your theta lying between minus pi to pi for which? Cos theta gives you negative root 3 by 2 and sine theta gives you minus half. What is that theta? Obviously, the answer here will be minus 5 pi by 6. Is that fine? Any questions? Any questions? Any concerns? Anybody? Do let me know if you have any issues, any concerns. So, for the fourth question, the answer will be 3 cis minus 5 by 6. Let me check who got this right. Okay. Why was that 3 by 2 in your answer, Anika? Three by 2. Krishnendu also 3 by 2 something. I don't know what is the reason why you are taking 3 by 2 there. Okay. Anyways, try out the fifth one now. Fifth one, give me a response on the chat box. Let's discuss fifth one now. So where should I write? Let me write here. So for the fifth one, you have your z as 2 cos pi by 3. 2 cos pi by 3 means 1 and 2 sine pi by 6. That is I into 1 again. So that is as good as this, isn't it? So if somebody is asking you to represent this in the polar form, of course, modulus is 2 and argument is pi by 4. Do I need to show how? Modulus is root 2 and argument is pi by 4. Okay. So this represented in polar form is root 2 cis pi by 4. Is this fine? Any questions? Any concerns? Clear, everyone? Okay. So now that we have completed this form, I'll also give you a brief idea about the Euler's form, right? Even though we are going to take it separately while we are doing one of the operations of logarithm, I just give you a brief introduction about the third form, which is the Euler's form. So please allow me to go to the next slide. Okay. So the third form of representation of complex number is called the Euler's form, given by the famous Swiss mathematician Leonhard Euler. So this proof that this representation that Euler basically figured out was, he basically figured out that r cis theta can also be written as r e to the power I theta. But remember here, theta is in radians. Theta is in radians. Okay. In the previous ones, you could have written theta in degrees. Nothing will go wrong here. But when you're writing it in the Euler form, this theta should be in radians. It cannot be in degrees. I'll tell you the reason why. At least a part of the reason I'll tell you. Okay. That means Euler somehow proved that this actually could be written as e to the power I theta. Okay. Now, how would he have actually proved it? One way was expansion, right? Many of you who were preparing for APs know the Maclaurin series expansion for cos x, sin x, and e to the power x. But that time when Euler was doing, these expansions were not into the picture, right? These expansions came a little later on when Brooke, Taylor, and of course after that Maclaurin started working on them. And Euler was much, can say, much senior to these guys. Means he was not in the same generation, right? There were almost 100 years of gap between them. So how he would have actually figured it out? So what he did was he was actually working on differential equations during those times. So what he did, he took cos theta plus I sin theta to be some variable x. I'm right now calling it as x. Okay. Then he differentiated both sides with respect to theta. Now, when you're differentiating cos theta, and only when theta is in radians, you can write the derivative to be negative sin theta, else not. If your theta is in degrees, this will not be the answer. Now, there's a reason for that as well, which I will discuss with you under limits chapter. Okay. Yes, this Taylor series, etc., they are not in your syllabus, but it doesn't hurt to know it. Okay. And derivative of sin theta is cos of theta. Again, this is to be applied when theta is in radians. So Euler was quick enough to understand here that if he would have taken I common, he would have actually got cos theta plus I sin theta. Because this minus 1, what is this minus 1? This minus 1 is actually I square, isn't it? So he wrote that minus 1 in front of sin theta as a I square, and then he took I common. Right? So he figured out that his dx by d theta is actually ix, because this is back to x. Here, click here. Right? It is back to x, isn't it? So then he separated the variables out like this and integrated both sides. Because as I told you, he was that time working on differential calculus, or you can say differential equations quite a lot. Now you tell me, if you have learned it in your physics classes, what is the integral of 1 by x with respect to x? Ln x, right? Or log x to the base e. And I being a constant, derivative of d theta is theta. And whenever you are performing a indefinite integral, you should always put a constant of integration. Right? So I'll put a c. Now, how do I get this c, or how would Euler have got this c? So he basically took the help of this fact that in this equation, when theta is put as 0, your x value will automatically come out to be 1. Isn't it? Put theta as 0, your x value will be 1. So that relation will still be valid here as well. So what he did, he put theta as 0 and x as 1. And when he did that, he ended up getting this as 0, this as 0, plus a c. That means his c was 0. Correct? So he put this back again over here and realized that log x to the base e is actually just I theta. So x could be written as e to the power I theta. That means he successfully proved that cos theta plus I sin theta could actually be written as e to the power I theta. This was a very, very interesting and important breakthrough in the field of complex numbers, because what was now written as this could also be written as r e to the power I theta. And this representation has a lot of utility, especially when you are doing operations like multiplication, division, or taking log of a complex number. So this representation saves a lot of your time there. And just out of general knowledge, if you put here theta value as a pi, so here if you put theta as a pi, yeah, you end up getting -1 as e to the power I pi. That is e to the power I pi plus 1 equal to 0. Okay. This equation was voted to be the most beautiful equation in maths, because in the same equation you have 0, 1, the basic units in mathematics. You also have two transcendental numbers, e and pi. You also have imaginary numbers, right? So this is you can say, where all these guys are coming to party together, right? So in mathematics, this equation was voted to be the most beautiful equation in maths. Okay, any questions here? Yes, Pranav, why not? You can prove it by using this. But we'll talk more about Euler little later on. This form has a lot of uses. We'll take this up little later on. Meanwhile, my immediate agenda is to start with operations on complex numbers. So let's talk about operations on complex numbers. Operations on complex numbers. So this has always been the trend in studying anything since childhood, when we were taught numbers. No need to copy the proof. Anyways, I'll share this with you. Okay. So whenever we learn something new, we know how to represent it, how to write it. Then we start doing some operations with it. Like when you were very small, you learned 1, 2, 3. Then maybe your mom, dad made you add them, isn't it? Addition came, subtraction came later on. In 3rd grade or 4th grade, you started learning multiplication. Same way, now you learn complex number. What is it? How do we represent it? Now we are learning some operations to be done on it. Okay. So the first set of operations that we are going to talk about is comparison. So we know in comparison, there would be equality comparison and inequality comparison, right? So when you say a complex number Z1 is equal to another complex number Z2, what does it mean? It means real part of Z1 is equal to real part of Z2, and imaginary part of Z1 is equal to imaginary part of Z2, right? That is to say, if your Z1 is A1 plus IB1 and Z2 is A2 plus IB2, right? Then it means Z1 equal to Z2, or let me write the symbol, Z1 equal to Z2 will imply what? Will imply A1 is equal to A2 and B1 is equal to B2. Okay. Is this fine? Any questions? Now, what about inequality? So if Z is not a purely real number, then note that you cannot say one complex number is more than, let me write it as Zi, or to be more precise, Z1 and Z2. If Z1 and Z2 are not purely real number, you cannot say Z1 is more than Z2 or Z1 is less than Z2, right? So it is abstract to say one complex number is bigger than the other or lesser than the other if they are not purely real numbers, right? So I cannot say 2 plus 3i is greater than 1 plus I. No, just because 2 is more than 1 and 3 is more than 2, you cannot say such things, because it is like, you are comparing two coordinates or you're comparing two vectors. That would be the right comparison. Can you say one factor is greater than the other? No, you can say its magnitude is greater than the other. Or you can say the angle made by it from the x-axis is greater than the other, but you cannot compare the vectors themselves. Okay. So unless until it's a purely real number, you cannot do such comparisons. Okay. Now, based on this, one small question came in one of the competitive exams. I know this is a very trivial concept, but one question was asked in the competitive exams. It said that if A plus BI is greater than C plus DI, then which of the following is possible? Or let's say, then which of the following is true? Or let's say just then, because you're only going to choose a possibility. Yeah, then option A, B is equal to D and not equal to 0. B plus B square plus D square is equal to 0. B plus D is never 0. None of the above. Nota. Let me run a poll for this. I'm putting a poll here. Please give forth your response on the chat box. Oh, sorry, on the poll. Okay. Should we stop the poll? Anybody who is still doing it or about to finish off, I'm giving you 5 seconds only. 5, 4, 3, 2, 1, and go. Okay. So, Nota lovers, only 2 people have said Nota. Let's have said option number B. Mostly have chosen option number B. Okay, now let's discuss it. See, if at all there is a comparison between two complex numbers, what did I tell you? It should be purely real. That means B and D should be 0. Else such a comparison will not become valid. But since the question setter has compared it, it means that B and D are 0 and A is greater than C. But that is not my point, A greater than C. What is my main important point is that B and D should be 0. So keeping in this in mind, which option is basically correct? Is this first option correct? B not equal to D not equal to 0? No, that is not correct. Here B and D should be equal. B square plus D square is 0. Yes, this will be valid because if both of them are 0, even their squares will be 0. B plus D will not be 0. No, if they both are 0, their sum will be 0. Right? So this is also not correct. And of course, one of them is correct. So Nota is also not correct. So absolutely right. Janta who has said option number B, B is the right choice. B is the right option. Is this fine? Any questions here? Okay. So with this, we now move on to addition of complex numbers. Shall we move on? Okay. Let's do addition of complex numbers. Now, if you have two complex numbers, A1 plus IB1 and A2 plus IB2, what happens when you add them? So when you add them, adding of complex numbers is like adding the like terms. Now remember, If somebody had given you 5 mangoes and 2 guavas, and then he gives you, let's say, 10 more mangoes and 6 more guavas, what do? How much is the total number of fruits you have? You add the mangoes with mangoes and you add guavas with guavas, right? In the same way, when you're adding two complex numbers, you add real with the real and you add imaginary ones with the imaginary ones, right? So you can write this as A1 plus A2 plus I B1 plus B2, right? Very simple operation. A simple example I can give you is, let's say Z1 is 2 plus 3I and Z2 is minus 4 minus 6I. So when you are adding Z1 and Z2, what will you do? 2 plus minus 4, which is minus 2, 3 minus 6, which is minus 3. Okay. But the sad part is, such an easy concept, JEE is not interested in, right? So JEE doesn't want you to test you, or doesn't want a question on this to be asked. Rather, JEE is more interested in whether you know geometrically what is happening when you are adding two complex numbers. So this is what JEE is basically looking out for in its aspirants, right? This is something which anybody can do. So for JEE, this concept or this operation is not as important as you knowing what is geometrically happening when you are adding two complex numbers. So let us talk about that, because that is more important from our competitive point of view. So geometrical significance of addition of complex numbers. Now let us say I have this as my Argand plane. Okay, and on this Argand plane I have two complex numbers, Z1 and Z2. So let's say I take Z1 here. Okay, you can take our example of A1 plus I B1. So this is like a coordinate or point A1 comma B1, and let me name it as point A. Okay, and there's another point, let's say Z2 here, Z2, which is your A2 plus IB2, and let me name it as B for sake of referring to it. Okay, let's say this is your point B. Okay, now can anybody tell me geometrically where do you think Z1 plus Z2 point should be located on this plane? Now don't ask me for A1 and B1 and A2 and B2 values. Can somebody geometrically know where is Z1 plus Z2 point lying on this plane without making any diagram, without making any value substitution? Sorry, of course you have to make a diagram, but not making any value substitution. In between A and B, that means you're saying here. But Pratik, between two coordinates, what lies? The midpoint, right? So the midpoint here will become A1 plus A2 by 2, B1 plus B2 by 2, right? Right? But this is not the Z. What is Z1 plus Z2? Z1 plus Z2 is nothing but A1 plus A2 plus I B1 plus B2, no? That means if you want to represent this as a point, it should have this as the coordinates, no? A1 plus A2, comma B1 plus B2. But your answer is half of the answer. So can you correct your answer? You are almost on the right track. Not use that. Somebody who said between A and B. Who was that? Pratik. Pratik, correct your answer. You are at half this point, but you have to make double. What will you do for that? See, what you did was, this is half of this, correct? So this is the midpoint. But I want to come to here, this position. What will you do? Of course, wherever it is, you'll double this distance, right? So see, in order to double a coordinate, whatever distance you are from origin, you have to double the same over here. So let's say this is, so you have to go the same amount on this side, correct? Isn't it? So you'll have to reach this point, correct? Now, how do you show this as a construction? How do you show this as a construction? Achha, tell me in which quadrilateral the diagonals bisect each other. Right, there you got the point. Parallelogram, Saket, beautiful, wonderful answer. So here, please have a look at it. Let us say if Z1 and Z2 were given to you, what you do is you make a parallelogram using these two adjacent sides. So how do you make a parallelogram? We all know how to make a parallelogram. Okay, so make a parallelogram like this. Make a parallelogram like this. This point of the parallelogram will represent Z1 plus Z2. Correct? Now, this makes us realize that when you are adding two complex numbers and you are adding it by using parallelogram law of addition, what characteristic does it represent? It represents the characteristic of a vector, right? So this is something which you have to keep in mind, that a complex number is nothing but it is like a position vector. A complex number is nothing but it's like a position vector. So when you're adding Z1 and Z2, think as if you're adding these two vectors, OA vector and OB vector. Getting my point? So let me name it as C for sake of referring to it. So OC vector is like your vector addition of OA and OB. Getting my point here, right? So this is something which I was telling you in the beginning of the session, that complex numbers, they not only behave like points, but they also behave like vectors, right? That is the reason why you can use your coordinate geometry as well as vector concepts to solve complex number questions. Understood? Any question, any concern as to where on the Argand plane is Z1 plus Z2 lying, and how is your Z1 and Z1 plus Z2 placed? Yeah, everything you can use. Okay. Now, from this geometrical interpretation, from this geometrical significance, comes out some famous or important triangle inequalities. So let us look into some triangle inequalities on complex numbers. I know I'm breaking. Some of you would be messaging me on the chat, sir, your voice is breaking. Internet is not that great today. Okay. So what are some important triangle? I would write important here because it's really very important. Important triangle inequalities on complex numbers. Okay. Now look at the very same diagram. Look at the very same diagram that you see over here. Okay. And I want everybody to focus on this triangle. The one which I'm showing with the pink color. Okay. So everybody please focus on this triangle. I'll name it as OBC triangle, right? OBC triangle, correct. So in this triangle, tell me in terms of modulus, what is OB? What is OB length? What is OB length? This length, how do you write this in terms of modulus? Ayyo, nobody's answering. Yeah, modulus Z2, correct. Correct. What is BC length? BC. Modulus Z1, correct. Because this length and this line should be same, isn't it? Because they're parallelogram at the end of the day. And what is AC length? Sorry, OC length. What is OC length? You'll say, of course, OC will be the distance of Z1, Z2 from the origin, which is mod of Z1 plus Z2, right? Now, we already know that in a triangle, the third side is always lesser than the sum of the other two sides. So can I say, my dear students, that mod of Z1 plus Z2 will always be lesser than mod of Z1 plus mod of Z2? But here I'll make a small change. I'll keep equality sign also, right? So this is your first triangle inequality that you get from the very same diagram. Note it down. So the sum of two complex numbers modulus will always be lesser than equal to the sum of the respective moduli of the two complex numbers. Okay. Yes, that would be my question to you, Krishnendu. Can somebody tell me when would they become equal to each other? When will they become equal to each other? Excellent, Saket. Okay, now Anika, you're saying they should be in the same straight line. So can Z1 be on one side of the origin, Z2 be on the other side of the origin and in the same straight line? Will that work? It's like asking you, when do you say vector x plus vector y is vector x plus y? When? Or when do you say magnitude of vector x plus y is same as the sum of the magnitude of vector x and vector y? Right. But in our case of complex numbers, we cannot say they are parallel and all. We'll say their argument should be equal. Right. When the argument of them should be equal. See, very simple. When Z1 and Z2 argument are same, what does it mean? That means these 2 points are moving and coming to the same straight line, isn't it? So this parallelogram will collapse, isn't it? Let me make a diagram here. See, initially Z1 is here. This is your origin. Z2 is here. Okay. So when you have the same argument, what will happen? This parallelogram will start collapsing, isn't it? So now focus on what will happen to this diagonal. So when these two comes together, what will happen? They will come as a straight line like this, isn't it? And in that case, your Z1 plus Z2 modulus will be equal to, so let's say here is your Z1 and Z2 both, correct? Let's say, I'm just assuming, or you may keep them separate also. Let's say here is Z2. Okay. So this plus this is this whole distance, correct? So that can only happen when they are having the same argument. Note this down. A question on this has been asked in the competitive exam. Okay. Any questions, any concerns? Now from the same figure, you can get one more identity that we already know from triangle as well. The third side of a triangle is always greater than the difference of the other two sides. Okay. So even if you don't write a modulus outside here, then also it is fine. But I've kept a modulus just to keep things positive. So the third side is always greater than, now I'm putting equality sign also here. So this is another inequality or another triangular inequality, which is very, very useful. So in a triangle, we normally know that the third side is always greater than the difference of the other two sides. But here I have included greater than equal to as well. And this is something which I will ask you little later down the line. But if you can answer it right now, also it is fine. But even if you're not able to answer right now, that is also fine. So when do you think when do you think the equality exists? Can somebody answer this? Even if you say no, I cannot answer it right now, it's fine. But I just wanted to see, just wanted to check if anybody can answer this right now. Okay, nobody is able to answer this right now. Okay, never mind. We'll come back to this. Okay, we'll come back to this, and then I'm sure after discussing few more important concepts, you will be able to answer this. No, Zaya, not really. Actually, we'll come back to it. I know you are not equipped enough right now to answer this. That's why I kept it as a question mark. I'll definitely come back to this when I discuss with you the subtraction of complex numbers. Okay. Okay. Any questions? Any concerns here? Okay. By the way, just to tell you here so that you don't get confused. Let's say this is your argument of Z1. Let's say I call this angle to be, well, let me use different colors maybe. I've already used yellow for this. So let's say this is your argument of Z1. Let's call it as theta1. And this is your argument of theta2, Z2. Let's call it as theta2. Please note that this is the argument of Z1 plus Z2. So let's say call it as theta3. So here, let me put a footnote. Theta1 is the argument of Z1. Theta2 is the argument of Z2. And blue color I will use to show argument of Z1 plus Z2. Okay. I hope here nobody has this feeling that argument of Z1 plus Z2 is necessarily theta1 plus theta2 by 2, right? It is not the average of it. It all depends upon what kind of a parallelogram you are actually getting. Okay. So who will tell me when is the argument of Z1 plus Z2 actually the mean of the argument of Z1 and Z2? Tell. Okay, that's a very simple question to answer. My question actually is, when do you think, when do you think this diagonal makes equal angles with this and this? So when is this and this angle equal? Jaldi bolo, fast. Or for that matter, in a parallelogram. Let me make a parallelogram. Okay, when do you think this angle and this angle will be equal? Saket, for a rectangle it is equal. These two angles are equal in a rectangle. If you are thinking like that, let me make a very skewed rectangle for you. Now, do you think this tiny angle is equal to this angle? Illa, sir. Yes, when it's a square. And in this case, it should be a rhombus kind of a figure. Okay. All right. So these are things which JEE will test you on. Right? So take these things quite seriously. It is not just about knowing that, oh, add the real part, add the imaginary part, and my job is done. No, that is not what JEE is interested in. JEE is more interested in is whether you are able to geometrically understand it. Getting my point? Yes, of course, when the adjacent sides are equal, or you can say modulus of Z1 and modulus of Z2, they are equal to each other. Okay. Any questions, any concerns? All right. So moving on to subtraction before we take a break, subtraction of complex numbers. Okay. Now for NCERT, it is sufficient that when you're subtracting two complex numbers, you should only be aware that you're doing this operation. You're subtracting A1 minus A2 and IB1 minus B2. Correct? But as I told you, this is not what JEE is interested in, right? JEE doesn't worry about these trivial issues. Again, is my voice breaking or is it fine? Not breaking. Okay. Now, how JEE takes it is Z1 plus negative Z2. So it treats it like a addition operation only, but now between Z1 and negative Z2. Correct. So let us do this on the Argand plane. Let's look into the geometrical significance. So now if I have, let's say, an Argand plane which has got Z1 and Z2. Okay. Let's say this is my Z1 and this is my Z2. Okay. Now I want to find out where is my Z1 minus Z2 complex number line. Now it is proper, Raj, or it is still breaking up? Audio and video are not syncing. Are you? So then what should I do? Should I just switch off my camera for some time? Okay. Now, first of all, we need to understand if this is Z2, as per my diagram, it is in the first quadrant, but ideally it could be anywhere. Where do you think is minus Z2 going to be? Right, it's going to be in the third quadrant because you have to take a mirror image of it about the origin, right? So if this is Z2, please understand minus Z2 will be somewhere over here. This will be minus Z2. Exactly mirror image about origin, right? Because when you're doing minus of a complex number, you are actually changing the real part and imaginary part sign of both. So it gets reflected about the origin, correct? Now, how do we add the two complex numbers? Let's say this is one complex number Z1 and this is another complex number minus Z2. How do we add it? We have already seen that we complete a parallelogram like this. Correct? This point here, my dear, this point will be your Z1 minus Z2 complex number. So this is again a parallelogram like the way we made for addition. Okay. So this is your location of Z1 minus Z2. Clear, everyone? Any questions? Okay. Now, a few things I would like here to understand here deeply because that's going to be important for you. Had I completed a parallelogram like this, and okay, let's say this is also a parallelogram, isn't it? This is also a parallelogram. Okay. Now tell me, this length, the one which I'm showing in yellow, and this length, the one which I'm showing in blue, are they equal? That means, is this length and this length equal? Of course they will be. Now, what is the important takeaway from this exercise? See, we all have seen from the diagram that this length, let me call it as A point, B point, this is B dash, and this is C. Okay. So we have all seen from the diagram that OC is mod Z1 minus Z2. Correct? And as you told, this is as good as an AB. Correct? What does this represent? It represents that mod Z1 minus Z2 is nothing but the distance between Z1 and Z2 point. Very, very important, you can say, geometrical understanding out of this exercise. So remember this, when you are subtracting two complex numbers and taking its modulus, it is nothing but it's the distance between those 2 points. Got it? Yes or no? Now something related to your coordinate geometry here. So let me add a flavor of coordinate geometry to this. If I ask you what's Z1 minus Z2 as per this point given to you, what will you say? You'll say, sir, X1 minus X2 plus Y1 minus Y2I. Correct? No? And if I say a modulus of that, what will you do? You will take the square of the real part, square of the imaginary part, and take an under root. Isn't this the famous distance formula that you have learned in coordinate geometry? That's the reason why I told you. In complex numbers, you will realize that there is a flavor of coordinate geometry as well as vectors. Clear? Any questions? Any questions? Okay. Now here, tell me which angle signifies, let me call this as of now as maybe capital X, just to give you just to give a name to it. Which angle here is the argument of Z1 minus Z2? Write it down on the chat box. Which angle? Tell me angle, this is the argument. Which angle? You can use your alphabets to signify that angle. I've already named all the points. Okay, so you're trying to say XOC, right? XOC, this angle, isn't it? Correct. So this angle phi represents your argument of Z1 minus Z2. Now, I have a small question for you all. Let us say I had not done all these things, but I have only made Z1 and Z2 on the Argand plane. Okay. Let's say I am a lazy guy and only made Z1 and Z2. Okay. Can you make some diagram to show me, or how will you figure out? That is my question. What is the argument of Z1 minus Z2? Here, fine, you figured out Z1 minus Z2 and everybody knows that this angle is the argument. But let's say I only made Z1 and Z2. Is there any way that I can figure out what is the argument of Z1 minus Z2? Which angle will you make? Which angle will you make? Okay. Now, all of you have done vectors, correct? Everybody has done vectors? You know how to find angle between two vectors? Pakka? Should I ask you a question? Okay. So let's say these are the two vectors. Okay. I'm asking you a very simple question. One vector is like this. Other vector is like this. Right? Let me call this as A vector. Let me call this as B vector. Right? Now tell me, what is the angle between these two vectors? I'll give you some options. I'll give you some options. Is it this angle? Let's call it as theta. Or is it this angle? Let's call it as phi. Which angle will be the angle between the two vectors? Anybody for theta? Anybody for phi? Let me know on the chat box. Excellent. Most of you are right. In fact, all of you are right. Phi is the answer here, not theta. Right? Why? Because when we find the angle between the two vectors, the two vectors must be connected tail to tail. Right? So one will be like this, other will be like this, and this is the angle that I will be getting. So that is your phi only. Right? Now, in the same way, when you want to find out the angle between When you want to find out the argument of Z1 minus Z2, please note that it is the angle between the vectors. It is the angle between the vectors connecting, or let me write like this. It is angle between Z2 Z1 vector and positive real Z vector measured from positive real Z direction, or measured from positive real Z. Now see, so if I have to find what is the argument of Z1 minus Z2, what I'll do, I'll make a vector from Z2 to Z1. This is what I've written, Z2 Z1 vector, like this. Okay. And this is the positive real Z vector. So think that this is one vector A and this is another vector B. Right? So what is the angle between them? If I want to find the angle between them, I have to slightly extend this further. Let's say I do it further. Let me remove this real Z from between. Okay. And let me extend this little bit more. Little bit more. Yeah, like this. Okay. So what's the angle between this vector and this vector measuring from positive real Z axis? So this is the angle that you're going to get, right? So here you don't have to make Z1 minus Z2 to realize it. So this itself will become argument of Z1 minus Z2. This is very important, my dear. A lot of questions have been asked on this, and people make a lot of mistakes related to it. Understood what I said? So just note this down. This is very, very important. So it is the angle between Z2 Z1 vector. So from Z2 to Z1 you make a vector, and you already know positive real Z axis. It is in this direction. What is the angle between them? Treat them like vectors. So what is the angle between them? And obviously you have to start from positive real Z axis so that you can know whether it is negative or positive. Unlike in vectors, there is no sign to the angle, right? You just mentioned the angle between them, right? Here you have to put a sign to it. So you have to see whether you are moving anti-clockwise or clockwise. Got it? So if I say what is the argument of Z2 minus Z1, then what will be the, how will you figure this out? So for this, what will you do? Same activity. Make Z1, make Z2, but this time your vector will be going from this to this, like this. Okay. Understood? And your positive real Z axis is like this. Right? So when you pull this back and also extend this a little bit furthermore, when you pull this back, starting from positive real Z axis, this angle, this will become your argument of Z2 minus Z1. Understood this? So for that, you don't have to locate Z1 minus Z2 or Z2 minus Z1 on the Argand plane. No, you can directly figure that out from Z1, Z2 location as well. This concept is definitely missing from NCERT and many of the good books as well. Understood? Any questions here? Okay. So on the basis of this, we'll take a small question before we take a break. I know our break time is long overdue. It should have been at 6:45, but I'll just take a problem because I want to take this concept to a logical conclusion, and then we can enjoy a break of 15 minutes. Okay, let's take this question. Let me see from the understanding of mod Z1 minus Z2, are you able to tackle this question? Yes. It's a simple question. And I know many of you would be doing a lot of things. Okay, let's look at this first. Can I write it like this? Mod of z minus 4 lesser than equal to 3. So as a person who has understood the geometrical meaning of mod z1 minus z2, how will you read this? You will read this as distance of, or distance between, let me write it like this, distance between z and minus 4 comma 0 is always less than equal to 3. Correct? So how should your z be located? How should your z be located? That is distance from minus 4 comma 0 is always less than equal to 3. Can we show that on the Argand plane? So on Argand plane, minus 4 comma 0 is here. So your z is moving in such a way that its distance from this is always less than equal to 3. So it is basically moving on a circle whose radius is 3. So it's always within the circle, isn't it? Yes or no? Correct? So your z is always on or within the circle. Your z could be anywhere in this. Correct? Understood what I'm trying to say? And by the way, it will cut here at minus 1 comma 0. And here it will cut at minus 7 comma 0. Anyways, we'll see what utility that has. Now the question setter is asking me, what should you think, what should be the greatest value of mod z minus 1? That means, if you read this like this, it means, what do you think is the greatest distance of z from minus 1 comma 0? So which point in this shaded area will be at a greatest distance from minus 1 comma 0? You'll say this guy. And how much is this distance? That is what they're asking you. How much is that distance? How much is that distance? 6. Problem is solved. The answer to this question is 6. That's it. Understood how easily you can solve this type of question if you are geometrically aware of what is this meaning of mod, what is this meaning of arg, right? Beautiful question. Okay, so with this we'll take a small break. Okay, let's have a small break. Right now the time on my watch is 6:02, but I'll consider 6:03. Let's meet at 7:18 p.m. Okay, after a small break. All right, enjoy your break. Now that we have done the subtraction of complex numbers, let's go back to the previous slide to answer that unfinished condition. So I'd asked you this question, that when do you think is modulus of z1 plus z2 equal to the difference of modulus of z1 and modulus of z2? Now can we try to answer this question? Anyone? See, basically what I'm trying to ask you, when do you think the distance between z1 and minus z2 is equal to the difference of the distance of z1 and z2 from the origin? No, not that easy. See, let's say z1 is here. I'm just taking a simple example. Z1 is here. Okay. Z2 is exactly diagonally opposite, means on the other side of the origin. Here, Z2. Okay. So if this is Z2, where will be minus Z2? You'll say, sir, minus Z2 will be here. Yes or no? Now, do you realize in this situation, the distance between Z1 and minus Z2, that is this distance, is equal to the difference of this distance, that is the distance of Z1 from the origin, minus this distance, correct? So now looking at this situation, what can you comment? You can comment that in this case, the difference of the argument of Z1 and Z2, difference of the argument of Z1 and Z2 should actually be a pi for this to happen. Now, why I have taken difference is because your Z1, Z2 argument, one of them will be, positive, other will be, whatever. The difference is what it should be pi. Okay. Whichever of the two is greater, that doesn't matter. The difference. Hence, you'll see I have put a tilde symbol. This tilde symbol means difference. So let's say if the first one is bigger than the second one, then it will become a minus sign. If second one is more than the first one, then it will become the second minus the first. Okay. This is very, very important because again, questions on this have been asked. Question on this have been asked in the competitive exam. Please note this down. Okay, subtraction is just a pure minus sign, Raj. Here I've used tilde. Tilde is basically for difference. Okay, any of them can be more than the other, right? So the idea is they must be on the same line, but in the first case, they must be on the same line and on the same side of the origin. So in this case, Z1 and Z2 must be on the same line and on the same side of the origin. And in this case, they must be on the same line, but on the opposite sides of the origin. Okay, so you may write it down as a remembering source. So O, Z1, Z2 lie in a straight line, and Z1 and Z2 must be on same side of origin. Okay, here O, this is comma by the way, O comma Z1 Z2 lie in a straight line, and Z1 and Z2 must be on opposite sides of origin. Clear? Any questions? Any questions? Okay. Now, having done subtraction, there are two more triangle inequalities that we are going to discuss there. Okay, so let's discuss two more triangle inequalities there. So may I now switch to the current page? Okay, let me switch to a completely new page. Pranav, break was till 7:18. Okay, don't worry. I'll just summarize whatever I have done. Not to worry. So now two more triangle inequalities we are going to talk about. Now we have already seen that. If these are the two complex numbers Z1 and Z2, this distance is what we call as mod Z1 minus Z2. Am I right? Okay. And this distance is mod Z1. And this distance is mod Z2. Correct? Any questions? Now from here also, two triangle inequalities will come up. The first one, mod Z1 minus Z2, which is your third side of this triangle, will always be lesser than equal to the sum of the other two sides. Okay. And here also I would like you to tell me, when do you think the equality will hold? When do you think this will be equal to mod Z1 plus mod Z2? Think and answer. Think and answer. When is the distance between Z1 and Z2 equal to sum of the distance of Z1 from O and distance of O from Z2? When will this happen? When will the equality hold true? Write it down on the chat box. Right. This is again when your Z1, O and Z2 are in the same straight line and Z1, Z2 lies on the opposite side of the origin. So this will also happen when difference of their arguments is pi. Difference of this argument is pi. Note this down. Oh, sorry. I was supposed to box it. Okay. So very simple. See, if let's say Z1 is here and Z2 is here somewhere, diagonally opposite. That means lying on the same straight line, right? So in this case, you realize that this distance is sum of these two distances from here to origin and from here to here. So you're trying to say mod Z1 minus Z2 is nothing but mod Z2 plus mod Z1. That is what is the equality talking about. Clear? Okay. Similarly, we also know that third side of a triangle will always be greater than the difference of the other two sides. Note this down. And just like for the previous case, please tell me, when do you think the equality will hold true? When do you think this guy will be equal to this? When? Write it down on the chat. When do you think the distance between Z1 and Z2 will be equal to difference of their distances from the origin? Imagine that situation. Imagine the moment you close your eyes and imagine, you'll be able to get the answer to it. Z1, Z2, the distance between them is difference of the distance of Z1 and Z2 from the origin. Maybe I'll draw it for you so that you're able to imagine that in a better way. See, let's say this is Z1, this is Z2. So when is this distance equal to the difference of this distance minus this distance? When they have the same argument, right? I've actually made it like this so that you can easily connect to it. Understood? So, just because some of you came late, I'll summarize this, else I would not have. Ayyo, I want to choose pink color. Yeah. So just to summarize triangle inequalities, note this down. Summary of triangle inequalities on complex numbers. First inequality was mod Z1 plus Z2 will always be lesser than equal to Z1 mod Z1 plus mod Z2. Okay. Equality holds when? Equality holds when? Tell me. When their arguments are equal, isn't it? We have already done this. Mod Z1 plus Z2 will always be greater than the difference of their respective moduli. Equality holds when the difference of their arguments is pi. Third, we did mod Z1 minus Z2 is lesser than equal to mod Z1 plus mod Z2. Again, equality holds when the difference of their arguments is pi. And lastly, mod Z1 minus Z2, which I just now took, is greater than the difference of the moduli of these, and again equality holds when their arguments are equal. Right? Guys, don't mug this up. Have this picture in your mind. You'll be always be able to address it. Okay. Any questions here? Any concerns here? Please address. This is the quick short summary of the triangle inequality. So these 4 triangle inequalities are important. Okay, so with this, we now move on to the operation of multiplication of complex numbers. Multiplication of complex numbers. All right, so when we have 2 complex numbers given to me in point form like this, so let's say A1 plus IB1 and A2 plus IB2 are 2 complex numbers represented in point form. Oh, 1 second. Yes, okay, Krishnendu, I'll go back. Better you can take a snapshot or something if you want to quickly have a copy of it and then write it little later on. Okay, thank you. Yeah. So what happens when you're multiplying these complex numbers, right? Now, I'm going to show you the operation that as per NCERT, you are supposed to be knowing. Sir, why only as per NCERT? Because this operation has no meaning for JEE people. For National Agency of Testing, whatever I'm doing, they are not worried about it. Okay. I'll show you what they are worried about actually with respect to multiplication. Yeah. So anyways, when you're multiplying 2 complex numbers, you multiply everything with everything. For example, you multiply this with this guy, 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 right? So ultimately what you're going to get is this A1, A2, A1, A2, right? Now, since I want to write real parts together, so I'll just do IB1 and IB2 first. So IB1, IB2 will give you I square B1, B2, which is actually minus of B1, B2. Okay. So real parts I have addressed. Then IB1 multiplied with this will give you IA2 B1. And A1 multiplied with IB2 will give you A1 B2. Okay. But as I told you, as a process, you should know it, because this doesn't have any meaning for us. So this doesn't help us to understand the geometrical significance of what is happening when you are multiplying complex numbers. Okay. So this is just a, you can say, dry or dead expression. Doesn't have any meaning geometrically for us. Now, you will understand the meaning when I do the same operation for 2 complex numbers written in polar form or written in Euler form. Okay. So now let me write down the same 2 complex numbers Z1, Z2 in polar form. So let's say my Z1 is this R1 cis theta 1. But right now I'm not going to write it as cis and bro. I'm going to write it like this. Okay. Now let's see what is happening. How did you get the minus sign? Okay. See here, Krishnendu. When you multiply these two, what do you get? IB1, IB2. What does it become? What does it become? I square B1, B2. And I square is minus 1. So minus 1 B1, B2. Got it now? Okay. No need to say sorry and all. It's fine. You will get doubts. Ask it. Right? Don't feel bad about asking a question. Yeah. Anyways, let's multiply these two. So when you're multiplying these two, now mind you, R1, R2 will get multiplied. Okay. And you will have to multiply cos theta 1 plus I theta 1 times cos theta 2 plus I sin theta 2. Okay. Again, let's do this multiplication like the way I did over here. But this multiplication will reveal something very interesting. Just wait for it. So this with this will give you what? Can I write it in shortcut form? I don't want to write cos, cos, sin, sin. So let's use shortcut notation. So this with this will give me cos theta 1, cos theta 2. This with this will give me minus sin theta 1, sin theta 2. Correct? So this will become the real part. Imaginary part you will obtain when you multiply this with this guy and this with this guy. So you'll end up getting imaginary part as cos theta 1 sin theta 2 plus cos theta 2 sin theta 1. Okay. Now all of you have done trigonometry with me. Now you cannot deny it. Right? All of you have done trigonometry. Tell me now, my dear. What is this? What is this? Cos theta 1, cos theta 2 minus sin theta 1, sin theta 2. Right, that is cos theta 1 plus theta 2. Correct? Similarly, what is this? You'll say sin theta 1 plus theta 2. In short, you have got an expression or you have got a complex number whose modulus is this. Right? This becomes your modulus of the product and whose argument is this. Or principal argument is this. Or argument is this. Right? So this tells us very interesting fact. What it tells us related to the geometrical significance is that if you are multiplying one complex number with the other, let's say I have a complex number Z1, okay, and let's say this is at a distance of R1 and this angle is theta 1. And there's another complex number, let's say here, I'm just taking some arbitrary positions, whose distance from origin is R2 and this angle is theta 2, let's say. Okay, where is Z1 into Z2 located? So this gives you an indication that Z1 into Z2 is located at a distance of R1 into R2. That means whatever was this distance, take a product of the two distances. So let's say this was 3 and this was 2, let's say as an example. Then how far from the origin will it be located? At a distance of 3 into 2. What is 3 into 2? What is 3 into 2? 6. Correct now? And what should be the argument? It should be the sum of the two arguments. Right? So as an example, let us say if R1 was 3 and theta 1 was, let's say, pi by 6. And let's say R2 was 2 and theta 2 was, let's say, pi by 3. Where do you think Z1 into Z2 should be located? At a distance of 6 and at an argument of pi by 6 plus pi by 3, which is pi by 2. So if you multiply, I mean, just taking an example as per our situation, it should actually lie here at a distance of 6, right? Let's say if this was 3, this was 2, this was 30 degree, and this was 60 degree, then this will be your position of Z1, Z2. That means at a distance of 6 and making an angle of how much? Making an angle of 90 degree. Okay, understood? Understood what is happening? This is important. This fact is important to us, my dear. Any questions, any concerns here? Okay. Now,
Should we take down the derivation? Is that important?
oh yes, why not? Take this on. See, don't worry about taking it down during the discussion time. In the discussion time, you just hear what is going on. Take it down when I share the notes with you. That time you put it on your, let's say if you're not able to copy because you are listening so, deeply, then put a star mark, then I will copy this once the note is shared. So that you don't lose out on the class time. Yes, Pratik. How far you want me to go up? Yeah, I'm very young now. Do you want me to go up? I'm just 40 years old. What's that bad joke? Yeah, which part you want to see here? Is this the part which you want me to show? Oh Oh, you thought I was 30. Thank you. I take this as a compliment. Wish I were. Okay. Done. Now, many people ask me, sir, there you told me the geometrical way of finding Z1 plus Z2. Right? You also told me geometrical way of finding Z1 minus Z2. Is there any geometrical way by which I can make some construction and get my Z1 into Z2? Yes, there is a construction actually. How? For that, you have to be very, very attentive. So put down your pens and listen to this very, very, deeply. Okay. 110% attention I want. So I'll be doing some construction here, but I mean, I'll not execute that construction. I'll tell you, this is the construction that you have to do. Okay. You can do it with your scale, protractor, compass, whatever you have with you. So this is the construction that you have to do. See, in order to locate Z1 into Z2 position, just take a point here. Let me just name them. Let's call this as O. Let's call this as A. Let's call this as B. Okay. Take a point P here, which is 1, 0. And I will justify my construction also. Whatever I'm telling you right now, I'll not just blindly tell you that this is how you find it. I will justify also why this construction will give me Z1 into Z2. Now connect this. Let me make it in yellow so that you can see what is the construction which I'm doing. Okay. So basically you make a triangle here OAP. So what is O? Origin. What is A? Z1. What is P? 1, 0. Okay. So similar to this triangle, you make a triangle like this. Okay. Let me reach this position. I'm just taking an orbit position. Maybe let's take this like this. Okay. So that I'm not biased towards landing on the imaginary axis. Okay, so what I'm doing right now is I am creating a triangle OBC. And here triangle OBC and OAP. Triangle OAP and triangle OCB, they are similar to each other. So you make this by construction. So by construction, you make a triangle similar to triangle OAP. Okay. Now what I claim here is that this C point will now represent Z1 into Z2. Interesting. How? Let me justify my words here. See, by the fact that you have made OAP and OCB similar, can I say this angle will be θ1 again? Agreed? Because this is θ1, so ये भी θ1 होगा. By construction, they are similar. Yes or no? Okay. Now hold on. If they are similar triangles, can I say OA by OP should be equal to OC by OB? Correct? What is OA? OA is R1. What is OP? OP is 1. What is OC? OC I don't know. Right? Let's keep it as OC itself. Okay. But OB is what? OB is R2. This length is R2, isn't it? See here, R2. Correct. So what becomes my OC value? R1 into R2. That means this point is located at a distance R1, R2 from the origin. And if you see the entire angle from here to here, maybe I'll use a red pen for that. If you see this entire red angle, how much is this? See, from here to here it is θ1, right? In fact, from here to here it's θ2, and from here to here it's θ1 again. So total angle here is θ1 plus θ2, isn't it? So clearly signifying that this position has to be your Z1 into Z2, because for Z1 into Z2, my modulus was R1, R2 and argument was θ1 plus θ2. So by construction, this is your location of Z1, Z2. Understood? Understood what I'm trying to say? So again, I'll show you the argument. See, from here to here, it's theta 2. You already know that. It's already that written on the figure. And this is extra theta 1. So overall, how much will this become? Overall, this will become theta 1 plus theta 2. Right? So there is a complex number located at C, which is at a distance of R1, R2 from the origin. And it is at an angle of, or an argument of, theta 1 plus theta 2. Clearly signifying that that position is the position of the product. Understood? Any questions? Okay. So here is an interesting fact. The interesting fact here is when you have several complex numbers like this, Z1, Z2, da 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 da, let's say till Zn. Oh, sorry. Cis theta. Okay. And you are multiplying them all. Let's say you are multiplying them all. Then what do you actually get? You actually get R1, R2, R3 all the way till Rn. Cis theta 1 plus theta 2 till theta n. But by the way, please restrict this argument between minus pi to pi. Because while you are adding them, it may exceed pi also, or it may go below minus pi also. Okay. That is, if you are multiplying several complex numbers, their modulus is the product of the moduli of all these complex numbers, and their argument is the sum of the argument of all these complex numbers. Somewhat like the log property, isn't it? Somewhat like the log property. But remember, if you are claiming this to be principal argument, you have to keep this between minus pi to pi. So this is very, very important. I would request you to again keep this in your notes. Ayyo. Yeah. Clear? Any questions? Okay, so for division also, we'll take up a similar concept quickly without spending too much time on it. The idea is more or less the same. This is something which you will be asked few questions on. So why I'm asking you to restrict it between minus pi to pi? If you want your principal argument, you have to restrict it. I'll give you an example. Let's say my Z1 was 2 cis 2 pi by 3. Okay. And my Z2 was, let's say, 3 cis 5 pi by 6. Correct? So if I ask what is Z1, Z2, what will you do? You'll say 6 into cis. Now this is 120 degree, this is 150 degree. So it becomes 270 degrees, right? 3 pi by 2. But remember 3 pi by 2, this exceeds the interval minus pi to pi, isn't it? So I can't write this as my principal argument, because principal argument must strictly be between minus pi to pi. So think like if you have covered 3 pi by 2 means you have covered this much angle, correct? So indirectly, what is the angle that you have to state when you have to state the principal argument? This part, isn't it? And how much is that part? How much is that part? Clockwise? Clockwise or minus? And how much is the magnitude? Pi by 2. So this is as good as this. Okay. So indirectly what I'm trying to say is that 2 cos 120, which is 2 into minus half, plus I sine 120, which is root 3 by 2, product with 3 cos 150. Cos 150 is minus root 3 by 2, plus I sine 150. If you multiply it, it's going to give you minus 6i. Right? So thanks to this notation that you don't have to do that, real with real, real with imaginary, imaginary with real, imaginary with imaginary, all those things. So that NCRT operations you don't have to do. You can get your results in a slightly faster way. Okay. Any questions? Any questions here? Okay, for division, let's now move on. So division of complex numbers. But before division, I have to take a prerequisite for it. What is the prerequisite for learning division? Prerequisite is you need to know conjugate. Okay. So I'll just quickly talk about conjugate of a complex number. Conjugate of a complex number, right? Because this is very important. Without conjugate, we will not be able to, find out the division by your operations. Okay. So see, what's the conjugate of a complex number? First of all, conjugate of Z is written as Z bar. Okay. In many international books, they will also write it as Z star. Okay. But since in Indian curriculum, this is the notation that we use, Z bar. Now, what is this Z conjugate of Z, or what is this Z bar? Simple. It means that if you have a complex number A plus IB, its conjugate will be A minus IB. That is, you just replace I with minus I. Okay. For example, if my Z is 2 plus 3i, then what will be the conjugate of Z? Simple, 2 minus 3i. Correct? If my Z is 3 minus 4i, then what is my conjugate of Z? 3 plus 4i. Correct? So whatever is the sign here, or you basically change the sign of the imaginary part of it. Simple. Let's take this minus 4i plus 2. Then what is its conjugate? What is the conjugate? 4i plus 2. Correct. Don't. I basically trying to trick people. They have changed sign here. No, this sign has to be changed. Understood? Now, how is conjugate and the complex number located with respect to one another? So if this is your complex number Z, where do you think its conjugate should be lying? Can anybody tell me that? So if this is A comma B, where should A comma minus B be lying? Any guesses? Any guesses? If you're changing the sign, right, mirror image about the real Z axis, right? Don't say X axis, is the real axis now. Okay. There you go. My thoughts are becoming crooked. Okay. Somewhere here, the Z conjugate will lie, right? So Z conjugate and Z are mirror images of each other. Z and Z conjugate are mirror images of each other. of each other about the real z-axis. Okay. Any questions? Okay. Now let us understand few properties of Z conjugate, because that is going to help us do the division process. So I'll take it from here. Properties of conjugate. First property, conjugate of a conjugate brings the same complex number back. That's a very obvious property. If let's say 3 plus 4i, 3 plus 4i conjugate is 3 minus 4i, and if you take again a conjugate, it will become 3 plus 4i again, right? So can I say on even number of conjugation, the complex number will not change, isn't it? So if I do 4 times conjugate, it will still remain the same. If I do 6 times conjugate, it will still remain the same. Clear? Second property, modulus of the conjugate is same as the modulus of the complex number. Very obvious. See how? If I give you a plus ib, what do you do for finding the modulus? What is the modulus of this number? This complex number modulus is under root of a square plus b square. Its conjugate will be a minus ib. So its modulus will again still be under root of a square plus b square, because anyways we are doing minus b square here, so it remains the same. So what basically we are trying to see here is that the distance of z from origin and the distance of z conjugate from the origin, they will both be the same, and that is actually obvious because they are mirror images of each other. So these two triangles that you see, let me name it OAB and OBC. OAB and OBC, they will be congruent in nature. So these two will be same. Correct? Argument of conjugate is negative of argument of z. Very important. So let's say if this was 45 degrees, I'm taking some angle, then this would be negative of that angle, minus 45 degrees, isn't it? So argument of z conjugate is negative of argument of z. Right? Now, if you add two complex numbers and you take their conjugate, it is as good as adding their respective conjugates. And same will go with subtraction as well. So if you subtract two complex numbers and take their conjugate, the same will be obtained by doing difference of their, or z1 conjugate minus z2 conjugate. This is very obvious. Please prove it on your own. Just take z1 as a1 plus ib1, z2 as a2 plus ib2. You will automatically get this result. Not a rocket science. Okay. If z1, or let's say if z plus its conjugate, okay, if you add z to its conjugate, you will always get a purely imaginary number, a purely real number, which is twice of the real part of z. So z and z conjugate will always be a purely real number, which will be twice of the real part of z, which is very obvious. So if I take z as a plus ib, what will be z conjugate? A minus ib. What will happen when you add them? You get 2a, and that is 2 real part of z. Okay. Similarly, z minus z conjugate will give you I times 2 imaginary part of z. Oh, I should have written it in yellow. Sorry. Else you'll get confused with the proof and the result. Yeah, I'll write it down again, not an issue. Any questions here? Same logic. If you subtract these two, what will happen? If you subtract these two, you will end up getting 2IB, which is actually I times 2B, right? Which is I times twice of the imaginary part of Z. Correct? Any doubt so far? Now, on the basis of this property, there are basically you can say auditors or corollary of this. Corollary means a very obvious extension of this. So the corollary of this is, if Z1 plus Z conjugate is 0, it means Z is a purely imaginary complex number. I'll say, sir, it comes from the fifth property itself, because if you're saying this is 0, you're saying real part is 0. That means Z doesn't have a real part. That means real part is 0. So it becomes a purely imaginary number. Isn't it? Obvious. And similarly, if Z minus Z conjugate is 0, that means Z is equal to Z conjugate, it means Z is a purely real number. Is a purely real number. So it's like saying 5 and 5 conjugate. Both will be 5, 5 each. No difference. What is the mirror image of anything which is on the real Z axis itself? The same quantity itself. Isn't it? Last but not the least, product of Z with its conjugate will always give you the square of the modulus. What is the proof for this? Proof is simple. If you have Z as A plus IB, Z conjugate will be what? A minus IB. So when you multiply both of them, what do you get? A plus IB times A minus IB. Okay, use your x plus y, x minus y formula. So it's x square minus y square. On opening this, this becomes a square minus of minus b square, which is actually a square plus b square. And what is that? What is that? That's the mod of z square, right? This is one of the very important properties. It will be used at so many places. Note this down. Z into mod z will be, sorry, Z into conjugate z will be mod z square. Okay. Any questions? Okay, now I'll give you two properties more, but I'll prove them little later on. For later on, Z1 Z2 product, or you can say product of any such numbers, let's say till Zn. If I take a conjugate of it, it is as good as the product of their respective conjugates. Okay, so a simple example would be for two cases. If I take Z1 Z2 conjugate, it will be Z1 conjugate Z2 conjugate. Okay, now this proof is very simple actually. You can prove it if you take the Euler form of the complex numbers, but I'll do it a little later on, not right now. And if you take Z1 divided by Z2 and take whole things conjugate, it will be Z1 conjugate by Z2 conjugate. So I'll prove this later when I do the Euler form. Okay, so proof using Euler form little later on. Euler's form. So these are the 7 properties that you should know with respect to the conjugate. Anyways, my main agenda was division. So we'll do that operation before we close for today's class. And conjugate and other operations, we will take some separate set of questions when we meet in the next class. Next class will be the last class for complex numbers. Okay. So let's complete the division operation right now. I hope you have copied all set of properties that I have done here. Saket, I wanted to actually start with calculus, because if I start calculus, you will be in a position to solve more questions based on this. Else, what will happen towards the end if I do calculus? Many of you will not get the appropriate time to do it. Hence, the agenda that I have in my mind was to start limits and derivatives with you in the next session. Okay, binomial is easy. It is not going to take, it's not a difficult topic. Okay, but calculus is something which most of you will find very new. And for new topics, you need time to practice, isn't it? Okay, so continuing with division. Division continued. So first of all, I will tell you the operation here. If I have two complex numbers, A1 plus IB1 and A2 plus IB2. Okay. And I want to divide one complex number by the other. Please note that when you're dividing one complex number by the other, this result will also give you a complex number only. Okay, let's say I call it as C plus ID. Now I want to know what is my C, what is my D in terms of A1, B1, A2, B2. Okay, so let's try to figure that out. How will I do that? So here I will have to take the help of my conjugates. So I will multiply and divide the entire expression with the conjugate of the denominator. So conjugate of the denominator will be what? A2 minus IB2. So what I am doing is, in order to find my C and D, I am multiplying and dividing with the conjugate of the denominator. Okay. So what will happen here? At least what will happen to the denominator? Who will tell me? Z into Z conjugate is what? Look at one of the properties which I gave you. Z into Z conjugate is what? Mod Z square, right? So what is the mod Z square here? A2 square, B2 square. Correct? And what will happen on the numerator? Numerator, this will multiply. This will give me A1, A2. This will multiply. This will give me plus B1, B2. Mind you, my dear, because I square is also there and minus will also be there. So it will give you plus B1, B2. Similarly, this and this will multiply and this will multiply. So what I will end up getting, imaginary part will be A2 B1 minus A1 B2. Okay. So just to write it as C plus ID form, this is going to be my C part and this is going to be my D part. But let me tell you, this operation doesn't give you any insight whatsoever related to what is happening geometrically. Yes, you have figured out your C, you have figured out your D, but this is just a dry expression. Maza nahi aaya sir isme, right? At least mujhe to maza nahi aaya bilkul. Right? For operation point of view, it is okay. But what is actually happening, this guy doesn't give us any insight about it. Okay. So now I will show you the actual geometrical activity which is taking place here. So let me just go to the polar form for these and then you will see what is happening. Shall I go to polar form? Okay. So if I do the same operation by choosing the polar forms of Z1 and Z2. So let's say my polar form of Z1 was R1 cos theta 1, I sin theta 1 and R2 cos theta 2, I sin theta 2. Okay. So let's find Z1 by Z2 here. So Z1 by Z2 will be R1 by R2 and of course we have cos theta 1. Process is same. Process is no different. I am going to multiply with the conjugate. In fact, I'm just going to multiply with cos theta 2 minus I sin theta 2 both in the numerator denominator. Okay. See what happens. Down in the denominator, you will get, so these two multiplied will give you cos square theta 2 sin square theta 2, which is actually a 1. Okay. Up in the numerator, you will see these two multiplies, these two multiplies. What you will get? You will get cos theta 1, cos theta 2 plus sin theta 1, sin theta 2. Okay. And you get this multiplied with this and this multiplied with this. So you'll get sin theta 1 cos theta 2 minus sin theta 2 cos theta 1. Okay, of course, I will also be here. So overall, if you see, it is actually becoming R1 by R2 cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. What does it actually tell you? It tells you that when you divide one complex number by the other, the modulus is the ratio of the moduli. And argument is the difference of the argument. Got it? So basically, it's trying to say that if you divide one complex number by the other, its modulus is the ratio of the moduli, and argument of Z1 by Z2 is the difference of the argument of Z1 and Z2. That is argument Z1 minus argument Z2. I'll repeat again. I know my internet is not that good today. So what I said here, Naren, was when you divide one complex number, when you divide one complex number by another, the resulting quotient or the resulting complex number modulus is the ratio of the moduli of these two, and the argument is the difference of the argument of these two. When I say difference, means argument Z1, the top one, minus argument Z2. Clear? Any questions? I'll give you a simple example. Let us say my complex number was 1 plus I. Okay. Or let's say I take 1 plus root 3i. Right? And my another complex number was, let's say 2 root 3 plus 2i. Okay. If I'm doing Z1 by Z2 and somebody wants me to get the modulus, I don't have to actually do Z1 by Z2 and find Z1 by Z2 by doing that multiplication with conjugate and all. I can directly jump and say it is ratio of their respective moduli. So what is the modulus of Z1? What's the modulus of Z1? Write it on the chat box. 2, absolutely right. What is the modulus of Z2? 4. So it will become a half. Simple as that. Okay. If I ask you, what is Z1 by Z2 itself? So for that, you need its modulus and you need the argument, right? So R cis, the argument of Z1 by Z2. Correct? So I've already told you that argument of Z1 by Z2 is the argument of Z1 minus argument of Z2. So as per our example, what is argument of this guy? Argument of this guy is pi by 3. Correct? Argument of this guy is pi by 6. So this will become pi by 6 again. So your answer will become half cis pi by 6. That's your answer. If you want, you can open it up and write it as a point form, whatever form you want. Clear? So this is the takeaway from this particular property. Any questions, any concerns? So we have almost covered the entire division process. Now, one question that will arise in your mind: how do you geometrically represent? How do you geometrically represent? What happened to my R here? Yeah, geometrical representation of Z1 by Z2. I will not prove it here, but I'll give you an idea how to locate Z1 by Z2. But obviously, I would leave this as a homework for you to verify. Okay. So please verify this when you are looking at this note. Please prove it. Okay. Now see, everybody, please pay attention. Very, very important. Let's say this is your Z1 position and this is your Z2 position. Okay. If I want to show where is Z1 by Z2, I'll first make a triangle. Let me call them as these points. Yeah. I'll first make a triangle OBP. And what is this P? The same old 1, 0. Okay. Now, I'll make a similar triangle as OBP like this. Okay. So this triangle, let me name it as OAC. So triangle OBP is similar to triangle OAC. Okay. Then this C point that you see here, this C point is your Z1 by Z2. Okay. So please verify this for homework because I will not take your much time. If not, we will take this up in the beginning of the first class. Right? Or do you want me to do it now and show you? Okay, I'll show you right now. So let's say this is R1, this is theta1, this is R2, and let's say this whole thing is theta2. Let me put it in white color. R2, this is theta2. Okay. Now since I have made a similar triangle, this guy is going to be theta1. So how much is this angle? How much is this angle? The red one. How much is the red angle? Isn't that red angle theta2 minus theta1? Let me name this guy as R1 because that is Z1 actually, right? And let me name this as theta1. Sorry for interchanging their subscripts. So I'll call this as R1, this as theta1. I'll call this as R2 and this as theta2. Okay. Now this angle will be, theta1 minus theta2. This whole angle. Correct. And what about this distance OC? So let us use our similar triangles concept here. OB by OP is OA by OC. So OB by OP is OA by OC, which means OB is R2, OP is 1, OA is R1, OC I don't know. So from here, can I say OC becomes R1 by R2? That is what we had got over here also. See here. R1 by R2. Okay? And this is the distance. And the argument is theta1 minus theta2, which is what we got here. Got it? So this is how geometrically you can locate your R1 by R2. So with this, I'll conclude my today's session. In our next class, we will take up few leftover concept of complex numbers. Thank you. Happy Independence Day to all of you once again. Bye-bye.
Thank you, sir.
Good night.
Good night.
Stay safe.
Thank you, sir.
Thank you. Thank you.